the idea that time is relative. For most of human history, time felt absolute. Ticked forward second by second, the same for everyone, everywhere. Unchanging, universal, certain. Then, in the early 20th century, one idea quietly shattered that certainty. Time, it turned out, was not fixed. Could stretch, could slow, could change. This is the story of the idea that time is relative, and how it transformed our understanding of reality itself. 1. Time before relativity. For centuries, time was understood as a universal background to existence. Isaac Newton described it as absolute, true, and mathematical time, flowing evenly without relation to anything external. This view matched everyday experience. A second felt like a second. A minute felt like a minute. Clocks across the world were assumed to measure the same underlying reality. This assumption shaped science, philosophy, and daily life. It worked until it didn't. By the late 19th century, subtle inconsistencies began to appear. Experiments involving light, motion, and electromagnetism produced results that classical physics could not fully explain. The problem was not with the experiments. It was with time itself. 2. The birth of a radical idea. In 1905, a young patent clerk named Albert Einstein published a paper that would permanently alter physics. His claim was simple, yet unsettling. Time does not pass at the same rate for everyone. According to Einstein's special theory of relativity, time depends on motion. The faster an object moves through space, the slower it moves through time, relative to a stationary observer. There was no universal clock ticking for the entire universe. Instead, each observer carried their own time. This idea challenged centuries of intuition. 3. The speed of light and the collapse of absolutes. At the heart of relativity lies a single constant: the speed of light. Einstein proposed that the speed of light is the same for all observers, regardless of how fast they are moving. To preserve this rule, space and time themselves had to become flexible. Lengths could contract. Time could dilate. Two observers moving relative to one another could disagree about how long an event lasted, and both would be correct. Time was no longer a backdrop. It became part of the physical structure of the universe. 4. Time dilation, when clocks disagree. One of the most profound consequences of relativity is time dilation. A clock moving at high speed ticks more slowly than one at rest. This effect is not an illusion or a mechanical failure. It is a fundamental feature of reality. Experiments have repeatedly confirmed this phenomenon. Atomic clocks flown on airplanes fall slightly out of sync with clocks on Earth. Satellites orbiting the planet must account for relativistic time differences to function correctly. Without correcting for relativity, modern GPS systems would fail within minutes. Time, quite literally, runs differently depending on where you are and how you move. 5. Gravity and the warping of time. In 1915, Einstein expanded his ideas further with the general theory of relativity. This theory revealed that gravity is not a force in the traditional sense, but a curvature of spacetime caused by mass and energy. The stronger the gravitational field, the slower time passes. Clocks near massive objects tick more slowly than those farther away. Near a black hole, time slows dramatically compared to distant observers. This means time is influenced not only by motion, but by gravity itself. Time bends. 6. A new picture of reality. Relativity forced humanity to abandon the idea of a single, universal now. Events that appear simultaneous to one observer may not be simultaneous to another. Past, present, and future depend on perspective. This does not mean reality is subjective. It means reality is relational. Space and time are woven together into a single structure. Spacetime. Objects move through it, shaping and being shaped by it. The universe is not a rigid stage. It is dynamic. 7. Philosophical consequences. The idea that time is relative raised deep philosophical questions. If time depends on the observer, what does it mean for cause and effect? Is the future fixed, or does it unfold differently for different perspectives? Some interpretations suggest that all moments, past, present, and future, exist simultaneously within spacetime. This view, known as the block universe, challenges the feeling that time flows. Others argue that human consciousness gives time its direction. Relativity does not answer these questions. It reframes them. 8. What relativity does not mean. Time being relative does not mean time is arbitrary. Relativity is governed by precise mathematical laws. It does not allow contradictions or paradoxes that violate causality. While observers may disagree about durations and simultaneity, they agree on physical outcomes. Reality remains consistent, just far more subtle than once believed. 9. What remains unexplained. Despite its success, relativity is not the final word on time. At the quantum level, time behaves differently. In attempts to unify relativity with quantum mechanics, time sometimes disappears entirely from equations. Physicists still debate whether time is fundamental or emergent. Is time a basic ingredient of the universe, or a byproduct of deeper processes? The answer remains unknown. The idea that time is relative did more than revise physics. It changed how humanity understands reality itself. Time is not a universal river carrying everyone forward together. It is a dimension shaped by motion, gravity, and perspective. The clocks we trust measure more than seconds. They reveal the structure of the universe. If this exploration expanded your understanding, consider liking the video and subscribing to Interesting Mind Hub, because the deepest ideas are often the ones that change how we see everything else.